Cameron Chamberlain is the cartographer. Tying Man, that's me. Is the coordinator. Danny Bullard is the calculator.
Slash bull wrangler.
We're in block G1, chapter 00. Problem 2.
Cross the problems out. Yeah.
So, after we calculate the average for the three variables, which is mass, which is m, the gravitational acceleration, which is g, and the height, which is g, we got
3/5 of no-go.
so the average of mass is 9.02. Mass is in kilogram. G is in meter per second square. This one is 9.812. That's it's funny. Okay, heights in meter, and that's gonna be 97.002. Alright, so after we calculate the average, we're gonna try to calculate the standard deviation, which we're gonna use this formula. This is the symbol for the standard deviation.
Sigma.
N is the number of
Iterations.
what?
Iterations or measurements or
yeah,
whatever.
yeah, of measurement that we have. And again,
Sigma, glorious Sigma.
I can hear you.
Good. You're welcome, Earth.
so xi is gonna be the value of each measurement, and then the x with the line on the top, it's gonna be the average.
So the sigma is the stop cam. It's the difference between the initial measurements and the average, and those are squared. And that's all the measurements to n. Since we had 5 measurements, n is 5. So the sum of all those divided by 4, because n minus 1 is 4, because n is 5. You take the square root of that, and that gets your answer for standard deviation, which for mass was, where is it? It's point. That's not point. Point. This isn't working.
Where's my point button? Mogo demands a point.
Can't stop. Stop. 0. Oh my god. 0.0353. How did you write so nicely, Ty? For gravity was
This is our first attempt at this. Whatever you get done,
0.011.
you get some partial credit. That's all.
And for height was
We'll get faster.
point 0.010271.
Okay, so the third part of the problem, after the two other part of calculating the average and the standard deviation, is calculating the standard error, which we're gonna take this value right here that we got, which is this sweet number. We're gonna take that
iPad writing master.
divided by the square root of n, which is gonna be the square root of 5. Whatever we got over here, we're gonna be dividing by the square root of 5.
You just wrote. So you have those values divided by the square root of 5. So for mass, we get, well, since it's standard error, it's plus or minus 0.02 for mass, plus or minus 0.005 for gravity, and, well, I'm gonna run out of room, plus or minus 0.005 for height.
So our last part is to calculate the standard error for the
we have to
potential
We
energy.
have to calculate the actual potential energy too. How about we have Cam
Oh,
put in? Let's have Cam
right.
put in the table, and then we'll be.
All right. Yep. All right. Chart.
And finally, we find the standard error. Standard error. Let me find my pen. Standard. Wow. Standard. Wow, that's hard to do. Standard error of the potential energy, which is this is the equation to find it. And first, we need to find the partial derivative with respect to m, which is just gonna be gh. Partial derivative with respect to h, just gonna be mg, and the partial derivative with respect to g is gonna be mh. And so therefore the equation for the standard error of the potential energy is gonna be g square times square plus mg times h square plus mh square times g square. That's it. We out of time.